Hi, my name is Oliver Kruger. I'm Senior FAE at Atmel UK, and today I would like to talk to you about our high voltage programming mechanism of our Atmel microcontrollers. One of the most common problems our customers are facing is to have incorrect fuse bit settings, which could result in the device not being able to communicate with any debug or programming interface and therefore unable to be programmed in any way. The only way out of this is our high voltage programming mechanism, which means applying a higher voltage level to our target device, as well as some dedicated program and control lines to our target board, which will then allow you to have access again to the fuse settings and change the settings back to the original state, allowing a correct communication again with our debug and programming equipment. And now I'm going to show you an example how this would work. This is our target board, an SDK 600 evaluation board. Just got three sections. There's a programming section, the top bit, so the board can program our target device. In the middle section we have our target device. In this case I've chosen Atmel 2560 device. And the bottom end you can then see all the ports and LEDs, switches, etc. that can communicate. Now on the right hand side here we have our interfaces, and that's our programming interfaces. The cable that's already connected is our JTAG interface. And on the bottom here we have our two so-called high voltage programming interfaces, which we're going to be using later on. Now first of all, what we have here now is an example project and from our Atmel Studio 6, which communicates with our target board, the SDK 600. What I want to do is initially I want to be able to check if our communication is working. By pressing on the device programming icon here, I can open the overall programming window, which then allows us to set up the interface and start communicating with the target device. And the interface, as chosen on the target board, is a JTAG interface. Once we set up these three interfaces, or these three settings, we press the apply button, which sets this all up. In order to see if we can communicate with the target device, all we have to do initially is just to click the read button to read our device signature. And in this case, you see we get a valid signature back. We have information about the target voltage. That means we can communicate with the target device. You see here on the left hand side the fuses, which is our non-volatile fuse settings area. We click on this one, you can see an overview about all the fuse names. See if there's a green tag to it, that means that we can communicate and we are able to change the settings of the fuse. And here on the top, these three here, this is our on-chip debug enable, which we have to enable, which we keep enabled for now. And here, these here, our JTAG enable and SPI enable, are used for debugging and programming purposes to communicate with the target device. At the moment they're both enabled, so you can see we can communicate via JTAG with the target board and have access to the fuse settings. Now what I do now is I'm going to disable those two. And once we do this, we program these settings to the target device. And you see shortly after we already get an error message back. You see here the icons here have changed to a warning sign, and if we now click on read, we get an error message back, so we cannot communicate with the target board via our JTAG interface. What I do now is, just to double check that we cannot communicate with the target board, I change our interface to the ISP interface. So I changed it here on the Atmel Studio device programming window, and also now on the target board. Now I've got the ISP interface, I apply, and I try to read the device signature. And you see, we again have an error message. The device is rendered useless at this stage. So the only way we can now still get to the fuses and change the settings again back to normal and be able to communicate with the target board, we use our high voltage programming mechanism. You can see here, these are the two headers for our high voltage programming. Connect them to the target board. There's one header for programming and one header for data. If we now choose on our device programming window the HVPP, the high voltage programming mechanism, if we then apply this, we apply a higher voltage level to the target device. By doing so, we have now set the device up for high voltage programming, and if we now read the device signature, we get a valid signature back, so we can communicate now with the target board. This now means that we have now access again to the fuses. You can see we have all the tags enabled again. We can now enable the JTAG interface and the SPI interface. We program it back to the target board. And now, in order to double check that everything's working again, I'll go back to our JTAG interface. We try the same again. JTAG interface, we apply. Read the signature, and now you can see we have access to our device again. The signature is valid, we have full access to our fuses again, and also our memories. This is basically how we can rescue a device that's been rendered useless by incorrect fuse bit settings, just by using our so-called high voltage programming mechanism.